All right, so we're going on to, this is like part 2 of our factoring review. So we are going to look at the back side, but before I do that, I wanted to go over the front side. A couple problems there on that star method. You know, you may have done these already because you're doing these ones here. You're doing the, again, these ones got the button, like it looks like a button there with a circle and an arrow in it. You're doing all those ones on your own. I will put the answers on Google Classroom for you as well. Those will be there. But I wanted to see, because we did the star method, when we have an A here, that does make it a little more challenging. We talked about the star method yesterday. I can review that again with you. I'll probably do that on one, but I do want to also talk about another method that a student in my last class asked me about, and I hadn't really thought about this one, but I think it would be good to show you just as an option of the star method, because star method can be straightforward, but I think this other method can be also helpful too. So I'm going to go over that one also. Let's see, I need to come back here. Okay. So you can maybe write this down somewhere where you might have some space, if you have any space anywhere on the front side, and you can kind of just see how I do it. Perhaps I'll do a couple of these ones at the bottom, maybe, where I have more space down here. I'll do one of these ones down here. Now what this method's called, it's called the box method, because you draw a box. It's actually like a 4-square box, just like when you were kids and you played 4-square on the playground. Let's just look at 4 here. So if I was to do this with the box method, so this would be our box method. So it's very similar to the star. We'll use a box instead of a star. So you can decide whether you like this one better or you like the star better. That's fine. Just to kind of give you an option. Or the guess and check method, like I said, is the old school method that I learned when I was young, and I wouldn't necessarily recommend that. For me, it just seems not so straightforward. So there's 4 boxes. The first box here, we're going to put in our A term. So our A goes here, which is just, actually I'm going to do a different color there, 3x squared. The last box, we'll call this one the last box as we kind of come around here. The last box we'll put in our C term, which is just an 8. Okay, and we could say positive 8, that's fine. If you want to put the positive sign, you can. These 2 boxes are going to come from getting our middle term here, but when we're doing this one, we have to still do A and C, right? So we know A times C, in this case, will be 3 times 8. 3 times 8 is A times C, and that equals 24. So we need to figure out what 2 numbers, same question, what 2 numbers now will multiply to give us 24? And if you come up here and look at your C term up here, positive 8, it's positive, so they'd have to add, right? We're going to add to get the 14. So what 2 numbers multiply to give us 24 that add to give us 14? Well, let's see. 1 and 24 are definitely not going to work. 2 and 12, does that work?
Yeah.
Yeah, so that's the ones we want, 2 and 12. So 2 and 12 are going to go in these boxes here. And since they're coming from this middle term, they have to have x's on them. So a 2x and a 12x. So that's filling in your boxes. Now, what we're going to do next is use that GCF that we learned yesterday, or reviewed yesterday, with our rows going across and our columns coming down. So top row here, these 2 terms, GCF from those 2 terms, 3 goes into 12, so 3 is a part of that GCF. And they both have an x. So you have to be good at the GCF to do this one. So this is the one, this is where it differs from the star. Okay, star, you don't need to worry about GCF. But this one you have to know GCF. So if you like doing GCF, if you're comfortable with that, this might be the one you want to use. Down here, this row, the GCF between these two would just be 2. 2 goes into 8, so 2 is our GCF between those two. First column here. Well, there's nothing in between the numbers that is in common, but they do both have an X. So we can pull X out on this one. That's what's in common between these two. So again, you're just looking at what's in common between those two. What's in common here? It's just the X. This last column, what's in common here? Well, 8 can't go into 12, but 2 is in common, but also 4 is in common, right? So we want to go with the GCF, the biggest one that's in common. That's the greatest common factor. So 4. 4 can go into 8, 4 can go into 12. The last thing to do now here is just to identify the signs, and we can identify them just like we saw before. If your C number here, 8, is positive, we know these have to be the same sign in the binomials. They both have to be this sign right here. They're both going to be negative because that's a positive. They are the same. That means they're the same sign, right? Same sign. When that's positive, they're both going to be this sign. So we can make the 4 here a minus. We can make the 2 here a minus. They're both going to be negative. And there's our binomials right there. One binomial is x minus 4 from this one, and the other one is 3x minus 2. We didn't have to do any reducing like you do on the star. Star, you do have to reduce at the very end, if possible. So it's similar, but a little different than the star. If you like this one better, you can use this one. This is just the box method. But again, I would use either the star or this box method instead of guessing and checking. I think this is just going to be a little bit easier to do. Here, let's try one more time. I'll look at 5 here. Box. Go across and down, make 4 squares. In the first square, it's going to be our a term, the 4x squared. And the last one, it's 5. Now, you don't have to have the sign here. I mean, you could put the negative 5 if you want to. You don't need it because you're not going to really worry about the signs until at the end, and you're going to look at this to see the signs. So you don't need that sign to be there. Inside here, you have to do A and C. So here, A and C, A times C will be 4 times 5. That's the A and the C number. So 4 times 5 is 20. So what two numbers multiply to give me 20? And here it is. On this one, you're going to subtract, because your C term is, the C here is negative, so subtract. To get the 19. Two numbers that multiply to give you 20, that subtract to give you 19. 20 and 1? Does that sound right? Yeah? Do you have a question?
You don't have to put the negative where you multiply?
Here?
No, where it says 4 times 5.
No, because we're just looking for the number. Yeah, the signs really don't matter until you get down to your final answer and you're trying to figure out the signs that are in between the binomials. Yeah. So here we said 20 and 1. So we could put 21. It doesn't matter which one you put in which either. You put 1 here, 20 here. They do have to have x's. So 1x is just like an x. You can even change that to just an x here. So 1x is just x on that one. Or you can put the 1 in front of the x if you want to. So now we do our GCF of the columns and the rows. So top row, just an x. It's the only thing they have in common. Bottom row, 5 can go into 20, so they have a 5 in common. First column here, 4 can go into 20, so they have a 4 in common, and they have an x in common. This last row, there's nothing in common. If there is nothing in common, you still have to put a 1. Okay? Even if there's nothing in common, you would put the 1. Here's where you look for the signs now. So we know that because this is negative here, they are different. The signs have to be different. Different signs. And then between the numbers here that you have, the bigger one's going to be negative. So what we're talking about here is really, these are going to be our binomials. And we can even put them down right now with the two empty parentheses. And we can see one's going to say 4x and a 1 in this one. This one's going to be an x and a 5. So between basically these numbers here, 1 and 5, which one's bigger? 5's bigger. So 5 is going to get the sign of this term. It's going to be negative here, positive, then here. Now, just like I said, we can always check these by multiplying. If you multiply 4x times x, you get your first term. That's right. If you do the outside, that's going to give you negative 20x. Inside's positive 1x. And if you put those together, combine them, that's a negative 19x like we have in the middle. Your last one's 1 times negative 5 is negative 5. It works. So that was correct. You can always just double check by just multiplying, and you can kind of do the multiplying in your head. So you might find the box method to be a better one than the star. If you prefer that, definitely use that. I would have probably showed you that yesterday if I remembered about it, but a student in 5th period is asking me. So when I looked at it again, I'm like, yeah, this is actually a good method. I forgot about this one. It's a good option. All right, let's look at the back. So you can do the rest of those, and you can use this box or star or one of those two. I would suggest to use one of those two. Okay, next page, on the other side, we have special ones. These are special factorings. First one is difference of two squares. So these ones actually have names. You know, it's not just a method, it's actually a name of what we would call this. And on these ones we see that it's exactly what it says its name is, difference of two squares. There are just two terms. See, on the front side we had 3 terms every time. Well, now we have just 2 terms here. And those 2 terms are squares. Both terms are squares. This is an x squared. 25 is a perfect square term because it's 5 times 5. Anything times itself gives you a perfect square. So 5 times 5 is 25. 25 is a perfect square term or number. X times x is x squared. That's a perfect square term right there. And the last thing is that it's a difference. They're different signs. X squared's positive. The 25 is a negative. So they're different signs. They're a difference. So what we can do with these, whenever we see a difference of 2 squares and we recognize, okay, there's 2 terms, they're both perfect squares, and they're different signs, they can factor to 2 binomials, just like the simple method and the star method, we're factoring to 2 binomials as well. So still the same thing as far as getting 2 binomials. The first part is just what are you squaring to get this first term? And this is just like the simple method because it's just got a 1x squared. So we are just going to say x times x. You are squaring x times itself. So x times x up front. But then for the second one, it's kind of the same thing. What are you squaring? What are you multiplying by itself to get 25? 5 times 5, right? So 5's go in the back. And now we just got to figure out the signs that go in here. Since this is a negative 25, and you're multiplying 5 times 5 to get this negative 25, should the signs be the same or different? Different. You got to get a negative. We got to make them different. Since they're the same number, it doesn't matter which one gets the positive or the negative because they're the same number. One's going to be a plus 5, one's going to be a minus 5. So you can put the plus first or you can put the minus first. It doesn't matter. Okay? That's it. You're done with that one. You can still check it as well. You can check to see if you're correct by even multiplying back through. Look at this one here. There are 2 terms. They're both perfect square terms. 4 is a perfect square number with 2 times 2 giving you 4. And then the z squared. You can see it's squared because it's got the 2. Exponent of 2. 1 is always a perfect everything. So it's a perfect square, it's a perfect cube, it's a perfect 4th power, 5th powers, and so on. You can see even my pink chart on the board up there shows 1 is the first one of every list because it's always 1 times 1. If you just keep multiplying 1s, you're still going to just get 1. Okay? So 1 times 1 is 1. It's a perfect square, yes. So we're going to make sure that we recognize, and they're different signs. This is a positive term, and this is a negative term. So they're different signs. So it will factor to two binomials. So we got to think about, what are we squaring to get the 4z squared? What are we timesing by itself? So just for 4, we're timesing what by itself? So what will we say here? Z, and what number? Well, no, we're not. What are we timesing by itself to get it for? 2 times 2, right? So a 2 and a z. 2z times 2z. If you multiply 2z times 2z, you get 4z squared, right? So yeah, that's how we break it apart here. 2z times 2z. And then for 1, that's just 1 times 1. We said that already. 1 times 1 gives you 1. Now we just got to figure out the signs. Signs are going to be just different because we're trying to get a negative 1 here. 1's plus, 1's minus. You can put the plus first or the minus first. Again, doesn't matter. We can check this. Let's say if we wanted to check to make sure this was correct. So 2z times 2z does give us this first one of the 4z squared. 1 times negative 1 gives us the minus 1 there. But what about our outside and our inside if I multiply those? The outside one here, 2z times 1 is a negative 2z. And then 2z times positive 1 is a positive 2z. What's going to happen when I combine those together?
They're gonna eliminate.
You're going to eliminate. They're going to cancel out. Exactly. That's why I don't have a middle term here. I don't have a z term. It's been canceled out. There's 0 z's, right? 2 minus 2 would be 0. So that's why we only have 2 terms on this one, because the middle terms canceled out on that one. All right, so you'll be doing these 4 here, just with difference of squares. They're all difference of squares there. They're all differences. They're all different signs. They're all perfect square terms on each one. So you'll do it again. Each one of these will be 2 binomials. All right, we're going to come down with one more special one on this side of the page. And that is factoring perfect square trinomials. So still going along with squares, perfect squares still, but now they're trinomials. So this is a little bit kind of in reverse from what we just did, when we just saw how they canceled each other out and we don't have a middle term. Well, this would now be if, instead of canceling them out, what if they were the same sign and they just got twice as big? You know, like if it was 2z and 2z, they were both positive, it would become 4z. Okay, that's twice as big. That's what we're seeing here, and we'll see that in the middle. Okay?
Can you get the ones from the last question?
I can come back in a minute, yeah. Yeah, I can come back, so we'll do that. I'll come back by the end for sure. So right here we can see that it's got a trinomial. Now what needs to be perfect squares? Just like on the difference of squares, the first term and the last term. That's the a and the c. That's what we have on the difference of squares, is a term and a c term, but we're missing the b term. So here we have an a term and a c term, and we have a b term, okay? But these two would have to be perfect squares. Now you might think, well, why can't I just factor this with a simple method? You can, okay? You can factor this with the simple method, and I'll show you that here in a second. But we can recognize that it's a perfect square trinomial, or a trinomial square, and that might make the factoring go even a little bit faster if we can recognize it. So if we think about this one, it would be the simple method because a is 1. So if you think about two numbers that multiply to give you 16, it would be 4 and 4, right? 4 times 4 is 16. Well, what about 4 plus 4? Does that give you the middle number here? It does. So that's telling you that this is a definitely possibly perfect square trinomial. The last thing to check is just that this here is a positive c term. C has to be positive in order for this to work. Okay? So you have 3 things to check to see if it's a perfect square trinomial. The a and the c have to be perfect square terms. And then when you figure that out, and you do, okay, what multiplies itself? What number do you multiply by itself? 4 times 4. If you say 4 plus 4, that would need to give you the middle one, 8, which it does. And this just has to be a positive for C term. Yeah, we're still going to get this 2 binomials. Just like simple method, we could break the n apart into two n's, right? Two numbers that multiply to give me 16, that add to give me 8. That's 4 and 4. They are the same number. They're going to be the same sign because it's a positive c here. They're both going to be positive 4s. So we're getting exactly the same binomial. That's what's special about this one. Because in the answers, they're not going to necessarily write it with 2 separately. They're going to write it a little bit differently as 1n plus 4 squared. So if you can recognize that this is a perfect square trinomial, you can go directly to just 1n plus 4 and square it. Okay? If you're going to do the simple method, you'll probably do this first, and then you can change it here. But this is kind of like the answer to these guys. Doesn't this look a little bit familiar from last chapter when we were doing graphing? And remember we were looking for h, right? We were trying to find h. This looks like where h is located. It's exactly where h is located. H is like -4 here. So this is how we would turn something into a vertex form. We would need a perfect square trinomial to turn it into a vertex form. Okay? That could come in handy sometimes when, if we're trying to graph something in standard form and we want to turn it into vertex form, we would have to use a perfect square trinomial to do that. I'll show you that eventually in a future lesson. So this is what we would see kind of as an answer right there for this factoring. So look at B over here. Now B does have an A number. Okay? So if we want to recognize that this is a perfect square trinomial, this is a perfect square term. 4 is 2 times 2, and then you have x squared. So that's perfect square. 9 is 3 times 3, so that's a perfect square as well. Okay? Now what you'd have to do to figure out if this is still a perfect square, you're going to have to multiply a times c, just like we saw in the star, right? Just like we saw before, a and c, which is going to give us 36. 36, what times itself gives us 36? 6. 6 times 6. What about 6 plus 6? And is that the middle number?
Yes.
Yeah, so there you go. And just double check that this is a positive here, and it is. Okay, your C is positive, so you're good to go. This is definitely a perfect square trinomial. So we can just figure out from this first term right here, what are we timesing by itself to get a 4x squared? 2x, right? 2x. 2x times 2x gives us 4x squared. And then what are we timesing by itself to get the 9? 3. So 3 is there. What's the sign of the middle term? Negative comes down. There is our binomial, and then just put a square on it. Put an exponent of 2. So that shows you there's 2 of them. Okay, you can't just say there's 1. There's still going to have to be 2. They're just 2 exactly the same. It's got to look like vertex form with, you know, the parentheses squared. Now, we could still factor this with the star method or even the box method if we want to. Let me just review the star with you just to kind of put this in perspective. If I did the star, and we did the A and C, that's the 36 number. It's a positive 36. Its middle term is negative 12. And it starts with 4x. So 4x would go here and here. And asking ourselves the question, what two numbers multiply to give us 36, that would add to give us 12, are 6 and 6. They have to be the same sign. They're both going to be negative, so negative 6s. And the last thing to do then would just be to simplify the sides. Reduce your sides if you can. And you can reduce these by 2. So this is where we're getting the 2 and the 3, right? So we'd see it's going to be, this is going to become a 2x here, and this is going to become a negative 3 here. That's what you'd use to get your binomial. This is going to be exactly the same on this side too. Okay, so you could do that. Let's put it side by side with the box. I did that pretty fast, didn't I? Let's see if I do it just as fast with the box. I would put the 4x squared here. I would put the 9 down here. And I'd see it, okay, 36 again. What two numbers multiply to give me 36? That will add to get the 12. It's the 6 and 6. The 6s are going in here. And now I got to get like terms, right? Or not like terms, common terms. So what's in common? Well, 2 is in common here. And don't forget the x's there, right? Don't forget the x's. So 2x is in common there. And on this one, it's a 3 is in common. Down this way, again, 2x is in common. This way, 3 is in common. So you get there's your 2x and your 3, and you just know they're both negatives. So you can see 2 of them, you only need 1 to say 2x minus 3 squared. So, I don't know, about the same amount of time, I guess. Just depends on if you're fast enough with GCF. If you're quick at GCF, then this could go kind of quick. If you struggle with GCF and seeing common factors between two terms, then star might be your better option because you don't have to use GCF for star. All right, so you have 3 of these. These are all perfect square trinomials right here. Okay. All 3 of those will factor to just like this. The answers will look like this, a binomial squared. It'll be like the x minus h squared part. That's what it'll look like for the answers for these 3. All right, let's come to other side. Factoring polynomials completely. I mentioned this yesterday. We do always want to make sure that you don't leave it still where you could factor some more. You want to make sure that you factored it as far as it can possibly be factored. Factoring it completely. The first thing that you always have to look for when factoring is the GCF. So you do need to do that first. Put that number 1. Step 1 is always GCF. If you don't do that and there's a GCF to pull out, you're going to have a hard time trying to get it out later. Okay? So you got to get it out first. Then you can kind of look at what's left and then decide, okay, should I use simple method? Should I use star? You know, do I got to use a difference of squares? What's left here for me to try to factor? But GCF definitely will always be number 1. So on letter A right here, we can see it definitely has a GCF. And GCF is between either numbers or letters. It could be both. It could only be one of them. We see both here on this one, though, on A, because there is a letter in every one. X is in every one. So you want to look at which one has the least amount of x's. That's the last one here, right? Just one x. That's how many you can pull out. Okay? You can't pull out more than what the least one has. Okay? This one only has 1 to take away from it. It only has 1 to give, pull out. So we can pull out 1x then from this whole thing. And then for the number 3, 6, and 18. Notice that 3 goes into all of those numbers. So we can pull out a 3. So our GCF will be a 3 and an x. This one has both. So when I do that from each term, starting with the first one, if I say 3 divided by 3, that would be 1. So our number is 1. We can write it or we don't have to. I prefer not to. Take 1x away. Well, it has 3. If I take 1 away, now it has 2. X squared. From the middle term, it is going to be positive, so I'll put the plus. 6 divided by 3 will be a 2 for a number. It has 2 x's here, and I'm going to take 1 away, so that leaves me with 1 left, just an x left. I'll put the minus sign down. 18 divided by 3 will be 6 for the number, and it had 1x, and we took it away. So it has no more x's on this last term. That's the end. Okay, so factoring completely now looks at what's left and says, okay, what could I do with this? Well, it's a potential, possible, simple method. Because it just has a x squared, a 1x squared here. Let's try using simple method. Let's put the 3x here, 2 binomials down, and just start working on it. This would be an x and an x, right? And now we got to ask ourselves the question, what 2 numbers multiply to give me 6, that subtract to give me a 2? So let's see, 6 and 1, would that work?
No.
No, so 6 and 1 doesn't work. What's the other option? 2 and a 3, right? Does 2 and 3 work? Do they subtract to give me a 2? 3 minus 2?
Yes.
3 minus 2 is not 2, right? So that doesn't work either. Any other options?
2 minus 4.
Well, 2 times 4 is not 6 though. So it has to multiply to give us 6. So there's only two ways to multiply to give you 6, right? 1 times 6, that's always the 1 in the number. And then 2 times 3. Is there any other ways to multiply and get 6? No. I mean, we could do 3 times 2, but you're still using the same numbers, right? There's no other way to multiply to get 6. And neither one of those ways will subtract to give us a 2. So that tells us that I can't do anymore. That's not going to be able to be factored anymore. So that means that this is our final answer. So I can be confident saying that's our final answer there. But if you just factor it and circle it right away, and you only do that and you don't even look at what's inside, it might be able to be factored and you would be wrong. If this can be factored still some more, then this would be the answer. We found out it didn't work. Simple method doesn't work, so it's no more. That's our answer right there. It's as far as we can go. Letter B over here has 2 terms, and it has some things in common first. So GCF first. What's the smallest amount of x's we see? Yeah, 2 of them right here. So that means we can factor out 2 out. We can pull out 2 x's. We can't pull out 4. This one only has 2 to give, right? What about our numbers? 7 and 28. Can 7 go into 28? Yes, it can, right? So 7 and an x squared. That's what our GCF is. So from the first term, 7 divided by 7 would be a 1 for a number. And I'm not going to write it because I don't need it. If I take 2 x's away from 4, that leaves me with 2 left. So it's an x squared for the first term, 1x squared. I'll put the minus sign down. 28 divided by 7 is 4. And we took both x's out, so there's no more x's for that 4. So now what we need is look at what's left. There's 2 terms. The only option for 2 terms you have right now is a difference of squares. And is this a difference of 2 squares?
Yes.
They're both squares, yes, and they're different, right? They're different, they're different signs, and they're both squares, yes. So we can factor this into 2 more binomials. So we start with x and x up front. And what number do we need to put in the back of each of these? They're the same number, right? What number times itself gives us 4? 2 times 2. So 2 goes in the back. Are they going to be the same or different signs? Got to be different. We're trying to get a negative 4 when we multiply. 1 plus 1 minus. That's our final factoring. There's no more we can do after that. That's as far as we can go. So when you do the ones there below that, yeah, you have one that's a binomial and 3, and the other 2 are trinomials, but they all have GCF. They all have a GCF to pull out. So make sure you pull out the GCF first, and then look at what's left to see what you can factor. All right, our last part here is now kind of bringing it all together in why are we even reviewing this? It's so that we can solve equations. It's so that we really can, in chapter 3, solve quadratic equations. And so to solve a quadratic equation with factoring, we have to use this zero product property. That's what's next. Using the zero product property. So let's just first write down, well, what does that zero product property mean? That means that you're going to set, once you factor it, okay, once you factor and get your factors, you're going to set each factor equal to 0. So once we have factored this, we're going to set each factor equal to 0, then solve each equation. Okay, so the first thing to do is to factor what we see, to factor the problem. Now, factoring is not always going to work. As we saw just a second ago, we couldn't factor that trinomial, so if you can't factor it, eventually we will see how to solve those that can't be factored. But for now, these are all going to be able to be factored. So first thing I got to do is notice that not everything is on the same side of this equal sign. in order to factor, I have to have everything on the same side. So I need to move this 10x over here to this side. And the reason why I want to move 10x and not bring these two over this way is because the highest term here has x to the third in it. And that's positive where it is. And I want to leave my highest term always positive. If that was a negative term, then I'd move it so it becomes positive on the other side. So that's why I want to move the 10x over here so that I leave this term, this highest one, positive. So we're going to subtract 10x first from both sides. So that now gives me 2x to the third power plus 8x squared, now minus 10x. And it's equal to 0 because these two cancel. So if you notice the problems you have down there, they're already equal to 0. Everything is on the same side. So this is kind of already been done. It's taken care of. You don't have to worry about this part on these ones. It's already equal to 0. But now we need to factor, and we start with GCF. I do see there's an x in each one, and also the number 2, 8, and 10, I can factor out a 2, because they all are even numbers. 2 can go into everything. So our GCF is going to be a 2x. That's going to be factored out first, GCF. From the first term, we take out the 2. That would now be a 1 here. We don't need to write it. We take out 1x. It leaves 2 of them left. 8 divided by 2. It's going to give us a positive 4. And we take 1x away, so now it's 4x there. Minus 10 divided by 2 is 5. And we took the 1x out, so there's no more x's for 5. And equals 0. But again, we got to factor it completely, so I see what's left here is a possible simple method. So we do want to try it again. It may or may not work like the last one we saw. So we'd start off with x and x for the simple method. It just starts off with an x squared inside here. Asking ourselves the question this time, what two numbers multiplied to give me a 5 that subtract to give me 4? So it only has one option, right? Just 1 and 5. Does that option work? Yeah, 5 minus 1 is a 4. So we can factor this one, yes, with the simple method. Now we just got to figure the signs. Are they going to be the same or different signs here? This is a negative 5 that we got to multiply to get. If it's negative here, is it the same or different? They're different because we have to get different signs. Multiplying different signs gives us a negative. Can we just put it wherever we want to? No. This positive is going to go with which number, 5 or 1? The positive is going to go with 5 or 1. It's got to go with the bigger one, yes. 5 is bigger. So the positive is for 5, which means 1 is the negative. So the bigger number between those two will always get the sign of your middle B term here. So now that's fully factored. Now we go to our zero product property. So I did the factoring. Once I've done the factoring, then I use this. I'm going to set each factor equal to 0. Then I'm going to solve each equation. So we have 3 factors on this one. When we do quadratics, we're only going to ever have 2 because it's the x squared function. This is an x to the third power function. Okay? So we're only going to ever have 2 when we go through chapter 3. When we get to chapter 4, we'll see some of these again, where we'll have more than 2. So first one's 2x. 2x equals 0. Set that one equals 0. I'm going to put a line down just to separate it. Second factor, x plus 5, that will equal 0. Line down there. Third factor, x minus 1, that equals 0. So now we solve each one of these. If you divide by 2, 0 divided by 2 is still 0. So this will be x equals 0. Here we would subtract 5 to solve this. And so now that's going to give me an x equals negative 5. On the last one, we would add 1 to solve this one. And that's going to give me x equal positive 1. So 3 answers for x we got on this one. Now these answers for x, because these are functions, are always the x-intercepts of the graph of the function. These numbers, 0, -5, +1, is where the graph of this function crosses the x-axis. They're the x-intercepts. That's what we're always trying to figure out here in chapter 3 by solving for x. Solving for x means we're trying to find these x-intercepts. Where would the graph cross the x-axis? Okay, so down below you have 3 of those. They are all set equal to 0 already. So you want to go back now and finish up just anything that has those arrows in the circle, all those problems, and then I will be posting the answers on Google Classroom so you can see what the answers are. But again, you can always check at least your factoring by multiplying back through. You can always double check by multiplying, and that's what you should do. The answers are there just as a way for you to double check to see that, yep, that was right, you didn't make any mistakes. All right, so I'll give you the rest of the time to work on that, and then just upload a picture of the front and the back side of this to Google Classroom, and then you can mark it done.